Greetings to all, and welcome to the 10th episode of NatureSpeaks. This program is brought to you by Himalayan Nature, and I'm him, working for JRSL in Kathmandu, Nepal office. For today's program, I'm supported by Dr. Tulsi Subedi, Director of Himalayan Nature and co-host of NatureSpeaks. As you know that in our last episodes, we have heard mostly about conservation of wild animals and their habitats. But in this particular one, you will hear information on environmental pollution, especially the mercury pollution in our environment and the implication to our health. Coincidentally, August is also the month celebrated as Water Quality Month in some parts of the world. Water sustains all life, and entire ecosystems depend on it for their survival. So it's very important that we have coincided this presentation in this month. So today we are fortunate to have one of the pioneering persons on environmental pollution research, none other than Professor Dr. Chhatra Sharma, to talk about this topic. Dr. Chhatra, let me just give you a brief intro about Dr. Chhatra. Dr. Chhatra completed his master's in zoology from the Central Department of Zoology, Tribhuvan University in 1996. He then persuaded for another international master's, followed by a PhD at the Norwegian University of Life Sciences. As part of his PhD, he worked on mercury and organic pollutants in fish, carrying out a whole lake experimentation. Dr. Chhatra and his team manipulated the population of top predator fish, which was the northern pike. Of course, we are talking about Norwegian context here, to study the cascading effects on lakes' biotic community and pollution levels. His publications during PhD made him top 20 researchers of the university in 2008. And he was the only student among the distinguished mass of senior researchers and professors on that top 20 researchers. On his return to Nepal in 2008, Dr. Chhatra joined Kathmandu University and taught there for more than a decade. In 2009, he was awarded Young International Scientist by the Chinese Academy of Sciences and got a fellowship for 2 years. In 2013 and 14, he worked as a postdoc fellow at the Lappeenranta University of Technology in Finland for 1.5 years. He received another fellowship as a PHEWA or PHEWA visiting scientist. Sorry for the wrong pronunciation here. At the Chinese Academy of Sciences again, and remained in China during 2017 and half of 2018. During this time, working with Chinese Academy of Sciences, he was selected as Professor of Academic Excellence by the Tribhuvan University. Therefore, he had to return back to Nepal 6 months earlier. Now he's working as a professor at the Central Department of Environmental Science at Tribhuvan University since July 2018. His research focuses on mercury pollution in biota, especially the fish, waters, sediments, soils, and atmosphere in the Himalayas. He has more than 100 scientific publications to his name, more than 60 of these in peer-reviewed journals. So Dr. Chhatra, welcome to the NatureSpeaks program.
Thank you, Dr. Hem, for inviting me in this prestigious gathering. And I'd like to thank Himalayan Nature for giving opportunity to speak about my research in this prestigious forum. Thank you.
Thank you for being with us today, Dr. Chhatra. One more announcement from me before passing it on to Dr. Chhatra. I wanted to let everybody know that this session is being recorded, and regarding the presentation by Dr. Chhatra, please ask questions through the chat options that will be made available just before the presentation is finished. And Dr. Chhatra will try to answer as many as the time will allow him. So now I pass the floor to Dr. Chhatra for his presentation.
Thank you, Dr. Hem and Dr. Tulsi from Himalayan Nature. And now I'd like to start my presentation by sharing the slides. Is it visible now?
Yes.
Thank you, all the distinguished guests and research fellows and colleagues. Now, the title of my presentation today is Mercury Pollution in the Himalayas. And in this presentation, I particularly would like to focus on mercury research that was carried out in Nepalese countries, foothills of the Himalaya in Nepalese territory, although we have some of the other findings from other parts of the world as well. But in this session, I'd like to focus more on the research that we conducted in this. Before going into our own research, I'd like to give some of the background information about mercury. Why is it so important? This mercury is an element which is regarded as non-essential from the point of view that it is not needed for the physiology of human body. That's why it is non-essential. But if it enters into our body, then it behaves as a toxic metal. So it is regarded as non-essential toxic metal. And so it is only one metal that remains in the liquid form in normal temperature, normal room temperature. It has a special property. And besides this, as a pollutant, it has two main properties. One, it has a very long range transport capabilities. Even if we produce or release this mercury into the atmosphere, generally it can easily vaporize into the atmosphere if we release elemental mercury by any activities. Then if we release this mercury into the atmosphere, it can travel very long distances through wind. By the air movement, it can, if we produce, for example, in the tropical region, by grasshopping effect, it blows with air and it can go up to the northern pole, southern pole, or the third pole like Tibetan Plateau and high Himalayas. We can find traces of mercury in those places where there are no local sources as well. So it has a very long range transport capabilities. So therefore it is found in every part of the environment, in atmosphere, in the lithosphere, or in soil, sediment, water, and it also passes onto the biota. So it is regarded as a global pollutant because it is pervasive in nature and it is found in every part of the globe. And besides this long range transportation capability, it has very important property that is called biomagnification. Generally, many metals, they can accumulate by the body of organisms when they consume these either through water or through food. So this mercury, if it is consumed, for example, if it is taken by the body of, for example, phytoplankton in water, then by consumption or through diet, it goes to the zooplankton, small insects, small fish, large fish, aquatic birds, etc., etc. And in transferring from one trophic level to the another trophic level, different forms of mercury that I will explain in next slide, they can magnify through by this food chain. Means if it travels from very long food chain, then the top predator fish, and mainly it is found in the aquatic environment. Methyl mercury is mainly found in the aquatic environment, which is neurotoxic in nature, and it can biomagnify. That's why if we consume top predator fish, for example, from polluted lake or polluted river, then there is very high chance that we consume large amount of mercury into our body, that passes into our body. That is one of the possibilities. That's why we have to be very careful during consumption. And another, if we talk about the background and significance of this mercury, initially It is also regarded as Minamata disease because initially it was or the mercury poisoning was detected in Minamata Bay of Japan during 1950s. Initially, some birds and some dogs and cats, they started to show unusual behaviors. Like that's why it was also called cat dancing, something like that. This is one of the symptoms of mercury poisoning. And in 1956, it became clear that it was caused by mercury. And this mercury was used by one of the main companies called Chisho company in Japan that was producing acetaldehyde, and it was releasing a lot of mercury as a byproduct because this company was using mercury as a catalyst in production of different chemicals. And this methyl mercury that was released into the Bay of Minamata actually bioaccumulated in different aquatic organisms, including fish, crayfish, and other aquatic organisms, which was main diet of the people living around this Minamata Bay. So thousands of people started to show symptoms, and thousands of people died, and many thousand people became sick of this mercury poisoning. After that, it was regarded as Minamata disease. And after that also, there were second and third episodes of Minamata disease in Japan. So now there are many conventions on this Minamata conventions, actually, COP1, COP2, COP3, something like that. So, and the world is now actually fighting to reduce this anthropogenically derived mercury into the atmosphere so that we can reduce mercury poisoning to humans. So one of the important features of properties of this mercury is that during this mercury, elemental mercury, it can easily vaporize into the atmosphere. So you can see it clearly here, Yg0 or Yg0, that is elemental mercury. When it goes in the atmosphere, it can stay there for longer period, around 80 days, for example, and it can be deposited, it can travel very long distances. And in atmosphere, it can be oxidized easily into this oxidized form, Yg2 with plus charge. Then it has this, when it is converted into charged mercury, then it can easily be transported back to Earth's surface with wet deposition through rainfall and snowfall, as well as dry deposition, like for example particulate matters from the atmosphere, they deposit on the ground. So when this mercury is deposited on the ground, then if it reaches in anoxic condition, for example bottom of the lake where there is absence of oxygen, this mercury can easily be converted into methyl mercury, which is organic mercury, which is extremely neurotoxic in nature. So if this methyl mercury is formed at the bottom or sediment of lake or sediment of ocean, then it can be utilized by benthic organisms there. So if it is consumed by benthic organisms, then it passes on to the food chain, and top predator can acquire high concentration of methyl mercury, which is protein bound, and it is released from the body very slowly. But if this methyl mercury comes to the light before being consumed by organisms, by this photoreaction, it can again be converted into elemental mercury and methane. So there is not much problem. So this elemental mercury does not have much neurotoxic impact, but methyl mercury, if it enters into the body of humans, it shows impact in nervous system, basically central nervous system and peripheral nervous system. That's why if pregnant women and small children consume mercury polluted or having fish with very high mercury concentration, then it can pass from the placenta to the growing fetus, and it can also cross the blood barrier so that it can reach to the brain of very small children. Especially it is very much dangerous for small children, means children with growing brain. It attacks on neurons. That's why it is regarded as neurotoxic. And so its impact on already grown people and very small children is different. So small children are highly susceptible to neurotoxins compared to adult ones. Now let's talk about very shortly on sources. It is released both by natural and anthropogenic emissions. Initially, it was said that natural emission was very large, because it was very difficult to calculate the natural emissions. And in midway around 2000, it was said that anthropogenic emission was actually high compared to the natural emissions. And now it is said that it was the data from 2010 from PRECIPITATION. They estimated that natural emission is 5207 ton per year due to many different activities like off-gassing from the volcanoes, geothermal vents at the bottom of the ocean, or hot springs, which actually consist of high sulfide. It also consists of mercury as a mercury sulfide. And when it comes to the surface, then sulfide is reduced and mercury becomes available to the atmosphere. So mercury-rich rocks and ores, evasion from the soil and water, once it comes to the surface of water and soil, it is easily evaporated into the atmosphere. And forest fire, natural forest fire also brings a lot of already tapped or already bound mercury to the atmosphere. So in addition, anthropogenic emission is causing some problem now. And some of the industrial emissions like coal-fired power plants is one of the main reasons for increasing anthropogenic mercury into the atmosphere. Some other activities like agriculture, mining activities, waste disposal, and deforestation, they also bring a lot of mercury that is otherwise bound to the or fixed. They are released into the atmosphere and becomes available to different organisms. And besides this, global mercury assessment by this UNEP in 2018 also collected some, estimated some data and said that it approximately 20% higher in 2015 compared to the estimates in 2020, especially for anthropogenic emissions. At the same time, it also states that human activities raised mercury concentration in the air or the atmosphere by 450% above the natural level, mainly as the legacy mercury. It says legacy mercury because once we release mercury, either through natural emission or through anthropogenic emission, it remains in the environment for a very long period. It settles at some time, again, it is remobilized. So once we release actually mercury in the atmosphere, it takes very long time to settle it or to bound it in the sediment and other parts. So it's continuously remobilized from one compartment of environment to the another compartment of the environment. So it's already mobilized. Suspension and resuspension, those are some of the phenomena that brings mercury to the biota again and again. Now, what is the main proportion? It's clear from those two graphs from Pessina et al. 2010. It's a little bit old data, but it's applies today as well. Now, fossil fuel combustion, particularly coal combustion, is the main activity that brings a lot of mercury into the atmosphere through anthropogenic activities. Now, we are mostly able to control the anthropogenic emissions, but natural emissions, it's really very difficult. That's why we are focusing more on anthropogenic emission of mercury into the atmosphere that actually brought, or that actually raised concentration of mercury in atmosphere by 450%. So other is gold minings. For example, artisanal small scale gold production and large scale gold production also release a lot of mercury into the atmosphere because mercury is actually extracted in form of mercury amalgam. When it is heated, mercury goes into the atmosphere and pure gold is extracted out. In that process also a lot of mercury is released into the atmosphere by gold mining. So these two different activities actually releases a large amount of mercury compared to other activities like chloralkali activities. We are producing caustic soda, especially to disinfect water and other things as well. So there are incineration and metal production through different ores, ferrous and non-ferrous things. So they are also releasing, but main releasing activities are coal burning or this fossil fuel combustion as well as gold mining, even smaller and larger scales. And when we start to talk about different continents, then Asia actually, it says that almost 2/3 of the anthropogenic emission is caused by Asia. And in Asia also, if we go to the next slide, it is clear that on the left side here, this Asia releases a large amount of, it's in ton, large amount of mercury into the atmosphere, mainly by this fossil fuel combustion and artisanal and small scale gold production. Those are main. At the same time, and if we go to which country is producing more, then it is very clear from this right hand graph in the right hand side that China, especially by fossil fuel combustion and this artisanal small scale gold production, they are releasing a lot of mercury in the atmosphere. So the two giants, India, although it's releasing very less amount of mercury to the atmosphere compared to China, it is on the second position. Only the United States and other countries, they are releasing mercury. So Asian countries are blamed for the release of release of mercury anthropogenically into the atmosphere. That is raising concentration of mercury, and that becomes available to different biota. So if we see the world scenario distribution of anthropogenic emissions, it is clear here that in the eastern part of the China, northern side of India, middle part of the Europe, eastern part of this USA also, they are producing mercury. They are actually producing mercury and releasing mercury into the atmosphere. Now let's go to our small studies in different environmental, different compartment of the environment in Nepalese context actually. Now we evaluated or we measured mercury in commercially important fish which are actually sold in the market that were cast from fishermen there. And this Niloticus, which is called also Nile tilapia, and this Mastasembelus armatus, and its long eelfish, and African catfish, that is Clarius garipinus. Those are the main fish that were sold in the market there. And we collected those fish and measured mercury concentration to find out what is the amount of mercury that is that enters into the body of consumers from Lake PHEWA. So we try to find out their relative trophic position. It does not give extra absolute trophic position by analyzing nitrogen isotope and carbon isotope. We found that relatively Mastasembelus armatus is at the higher position, trophic position, compared to this Clarius garipinus and Nile tilapia. Then similarly, higher the trophic position, higher the mercury concentration. It shows very good relationship. In addition, we also try to find out how much is the proportion of methyl mercury, that is organic mercury, found out of total mercury in fish in Lake PHEWA. So from upper right graph, this blue graph, it tells us that more than 86% of total mercury, which is found in fish, is found in the form of methyl mercury, that is organic mercury, which is highly neurotoxic. And that is the main poisonous form of mercury that passes onto the organisms. So this there are many other places where more than 90% of mercury is found in form of methyl mercury, and in some cases only 50% of the total mercury is found in methyl mercury. But in case of Lake PHEWA, more than 86% of mercury was found in the form of methyl mercury. So that actually is the neurotoxic part of neurotoxic form of mercury that passes to the human body. And we also try to find out what is the bioaccumulation and biomagnification of those mercury through the food chain. But I must say here that Lake PHEWA consists of 28 fish species, and we actually analyzed only 4 species. And due to less number of another Tor putitora, we analyzed 3 fish species here to show biomagnification. And worldwide scenario of biomagnification rate, actually it is calculated the slope of this regression or delta nitrogen, how much mercury is there, that is the biomagnification rate. They calculate it. So in Lake PHEWA, it is very small actually. And the reason for this very small rate of biomagnification could be that it does not represent, those 3 fish does not represent whole fish community of Lake PHEWA. If we collect all fish community or different fish community, fish species from Lake PHEWA, then this biomagnification rate could be different. So it is not representative, but we can get an idea that biomagnification rate in this Lake PHEWA is less compared to different other parts of the globe. We also try to find out fish from other different places. For example, what could be the mercury concentration in fish from river? That's why we analyzed fish from Indrawati river, especially this, we call it Asala Macha, Schizothorax. And its concentration is really small or very less compared to lake fish, because in river, it flushes out very quickly, so it removes mercury concentration from water very quickly. Therefore, concentration of mercury in this river fish is comparatively less in other parts of the globe also. And we also measured mercury concentration from Jagadishpur river reservoir, and it's under review now. Actually, it is not published, and we already submitted it. So here we can clearly see that trend is different in river fish here and reservoir fish here. With increase in length, if you go to the left graph, with increase in length of fish, mercury concentration is declining. But in Jagadishpur reservoir here, with increase in length, mercury concentration is increasing. Generally, worldwide scenario is that with increase in length or increase in age, because those fish are exposed longer time with mercury pollution, that's why they actually retain large amount of mercury on this body, because excretion rate of this mercury compound is very slow. But in case of this Indrawati river, especially mercury into the organism enters through their diet. So this, what happens here for the schizothorax, when they grow in size, after attaining certain size, they switch their diet. So the smaller schizothorax, they consumed zooplankton and macro insect larvae, which are actually higher in tropic position. But when they grow in size, they switch their diet towards plant parts, which are from the lower tropic level, and they contain less mercury concentration in their body. That is one of the reasons that even though they grow in size, their mercury concentration declines, because they switch their diet. And one of the major route of mercury to the organisms is their diet. That's why this is one of the reasons that with length mercury is declining in schizothorax. But in most of the lake waters, if fish is not changing its diet throughout its life, there is no change. It goes on increasing with its age or length. So here comes then, how much fish can we consume? Actually, it's from 2010 data, a little bit older, but it's still valid. So how much fish we can calculate, how much fish can we consume without having adverse health impact in our body? Generally, FAO and WHO have clearly said that there is provisional tolerable weekly intake, means in 1 week how much mercury can enter into our body without having adverse health impact. That is 1.6 microgram per kg body weight. So if this amount of mercury goes per kg body weight into our body, it does not show any bad symptoms or any adverse impact on our health. There is no mercury poisoning. So we calculated for a 60 kg person. Actually, I could have calculated for 70 kg. Mostly people are a little bit heavier, but I calculated it for 60 kg person by consuming 1 kg of different fish. What is the amount of mercury that goes into the body of consumer? For tilapia, since it has lower concentration of mercury in its body, it's only less than 0.3. And this spiny eel, which had highest concentration among those 4 fish species, even this, if we consume 1 kg of this fish, a 60 kg person generally receives 0.8 microgram of mercury into its body. So it means that in a week, even the highest mercury containing this fish, we can consume 2 kg of fish without having adverse impact. It's very safe actually. Compared to other parts of the globe, generally they exceed very high mercury concentration. So fish from Lake PHEWA is safe. Generally, I assume that we never eat more than 2 kg of fish per week. But if we consume more than 2 kg in a week and not consuming fish in the next week, then there will be no problem. So, and what is the mercury concentration in lake sediments? We collected lake sediment from BIOGEOCHEMICAL, one of the high altitude lakes in Nepal, in Mount Everest National Park area. And we calculated here, our team calculated history of mercury accumulation in lake sediment for 200 years, and we try to find out what is the scenario, whether it's in the increasing trend or decreasing trend. It clearly shows here that mercury concentration actually started to increase after industrial revolution, and it is further, actually more increment was found after World War II. After 1945 50s, mercury concentration started to increase in lake sediment. That means, and when we compare with the overall production of mercury, mercury by the different industries in the world, it shows the similar pattern. So in lake water also, we measured mercury concentration in Gosaikunda from high altitude, and another from Lake PHEWA, which is in the urban area, mid hills of Nepal. We compared mercury concentration in different depths of water body. Both are nearly 24 meters in maximum depth. So we collected samples from there. And it was seen that Gosaikunda, actually it has higher concentration of mercury compared to Lake PHEWA. And what could be the reason? Actually, when we talked about long-range transportation, this Langtang area, it receives wind from Kathmandu Valley. And in Kathmandu Valley atmosphere, it contains a high amount of mercury concentration. So that could be one of the reasons that wind blowing through Kathmandu Valley to Langtang area may have deposited mercury concentration in Langtang area, and that might have increased mercury concentration in lake waters compared to Lake PHEWA area, especially there. Long-range transportation could be less compared to this Langtang area. That could be one of the reasons. Now, our team, actually, Lekendra Tripathi, he collected some of the soil samples from this, when he traveled many times to Gosaikunda, I think around 10 times. He collected soil samples from different altitude to find out what is the concentration different altitudes in soils. And he collected soil samples from surface 0 to 10 centimeter depth and another from 10 to 20 centimeter, and tried to find out relationship with altitude and total organic content of the soil. And it was clearly seen that mercury has very high affinity towards organic content. Higher the organic content, higher the mercury concentration. If we move from lower part to the high altitude area, soil formation is less, soil content is less, organic content is less in the soil in high altitudes. That is one of the reasons that soil actually has a less concentration of mercury compared to low altitudes. And in another atmosphere, another research in atmosphere, we collected these aerosol particles by using TSP sampler for 1 year in 2000, from 2008 January to December 2018. In 18, we collect samples, and now I said it's submitted. Probably it will be submitted today or tomorrow. Lekendra Tripathi is working on it right now. So it clearly shows that Kathmandu, it has higher concentration of mercury in aerosol particles compared to Dhulikhel, which is outside of the valley. So it also gives an indication that due to different anthropogenic activity, we are releasing a lot of mercury in the atmosphere from the soil particles and from the traffic as well by burning fossil fuel. So we are increasing concentration of mercury in the atmosphere in Kathmandu Valley, which is actually very less outside valley. For example, very nearby Dhulikhel area, it has less concentration, which is comparable to clean cities around the globe. But in Kathmandu, is comparable to many cities in China and India, which are polluted. So it also clearly shows that Kathmandu atmosphere has higher concentration, and we should not ignore the anthropogenic activity, local sources or resuspension of already deposited mercury in the soil particles. And in addition, it shows that during monsoon, mercury concentration in the atmosphere declines because mercury rainfall washes out aerosol particles there, and with aerosol particles, mercury also is deposited in Earth's surface. So that's why mercury concentration is lower in atmosphere during winter months. And there is one more research in Jomsom, actually another part across the Himalaya, north of the Himalaya. Again, Lekendra Tripathi led this research, and he collected this precipitation sample for more than many years there and published an article. And it says that the mercury concentration in precipitation in that part of across the Himalaya, actually, it shows negative correlation with the precipitation amount. Higher the precipitation amount, lower the mercury concentration. Probably it was out the mercury that is present in the atmosphere, so the rainfall, which we collect later, contains less amount of mercury. And in the same time, he also tried to correlate this mercury with other ions like calcium and magnesium, which show crustal origin. And it also shows that the mercury there in the Johnson Reserve could also have crustal origin. Besides this long range transportation, crustal origin is clearly seen in those mercury pollution. So those are some of the parts research we did. And if time permits, so very shortly, I will go to this Norwegian fish, which I used during my PhD thesis, because it shows a little bit clear scenario compared to my those research in Nepal. So here, when we collected different organisms from Lake Orungen in Norway, it showed two different food chains. One, these three fish species there, and another rod, one species invertebrates and plants. So mercury, and actually, they are not directly connected with each other through food. So they are related to different, they are actually from different food chains. So when I try to find out this bioaccumulation factor or biomagnification rate there, then it says that EHG increases with the trophic ocean, and which is a clear biomagnification process. And here also, these two fish actually, they are top carnivorous fish. And this small fish has higher concentration than this. This is the top predator. Pike is the top predator. However, this perch also consume this roach fish, which is diet of both of the fish. And here actually this small fish has higher concentration than this larger fish. That is one of the reasons, because when fish grows very fast, then total amount of mercury per kg body weight of fish becomes diluted. So it is called growth biodilution. So fish which has higher growth rate, they will have less concentration of mercury compared to fish which have slow growth rate. So this smaller fish, it grows very slow, so it has higher concentration, and this larger fish, it grows fast, that's why it has little bit lower concentration. And both of them consume this roach, same fish species. And another fish which actually from different food chain that consumes mostly plant parts, and it has lower concentration of mercury. So to end this seminar, I'd like to go a few slides, only a couple of slides, by mentioning where are we using this mercury? This mercury is, especially elemental mercury, is used in chloralkali, specialty produce, caustic soda, dental fillings or dental amalgam, gold mining, electrical equipment, and preparing other instruments. And same charged mercury, Yag+2 inorganic form, is used in electrical equipment, batteries and lamps, skincare products and medicinal products, etc. And there is also another inorganic form, Yag with one charge, that is electrical equipment, batteries and medicinal products. Whereas there are other organic forms also. This methyl mercury, actually, it is not used for any production, but it is neurotoxic and it causes problem to human health. And it goes to human body through diet, particularly from contaminated fish. And one of the main sources is polluted sediment, where the sediment, especially in sediment, there is anoxic condition, and this anoxic condition creates methyl mercury. And another phenyl mercury, actually it is another organic content, and that is used as fungicides and pigments. That's why agricultural activity also releases large amount of mercury to the atmosphere by using those fungicides and other paints also as well. So here, if we see out of those, electric industry usage means releases more than 50% or uses more than 50% of mercury out of total mercury production in the globe. So there are different ways of mercury reduction actually. So I'm just putting some of the points here, like if there is source, then we can control it at source before it is being disposed to different like atmosphere or water, etc. That is more good way to control the source. Like waste stream capture, we can also capture or gather some of the mercury that flows from the drain to hospitals, so that we can release them to other to reach to the lakes and other streams. So if this is found in higher amount, for example, in sediment of a certain lake, then we can prevent release of that already bound mercury in the sediment to the water column. That's why we can cap it either by plastic covering or by soil, etc. We can cover the sediment which are high in mercury concentration, so that they are not released in the environment for resuspension again. So another other mechanisms are phasing out mercury added products. Now in Nepal also, those some of the mercury lamps, they are banned, and it is being replaced by lead, etc. And reduce dependency on fuel burning, especially coal burning. If we reduce this dependency on fuel burning for electricity production and others, especially by China and India in Asian countries, then we can reduce its release into the atmosphere. But it has a very huge cost, I believe. It changes economy. And use of technologies. These technologies actually are very expensive, as mentioned by different documentations. Use of technologies is possible so that we can reduce the emissions, like fabric filters, use of electrostatic precipitators, and dust scrubbers. There are different techniques, but those are highly expensive. And it's not sure that whether industries are using those technologies to reduce this emission of mercury to the atmosphere. Now, another, what we can do personally is avoiding fish from highly contaminated water bodies. We know that fish is excellent and very good for the health of human body, but if fish from highly contaminated water bodies are avoided for consumption, we can reduce mercury poisoning into our body. For example, from not using fish from Bay of Minamata and other like tuna fish. Some of the tuna fish, they also have higher concentrations. So there is always debate which fish should be used or so. That's why there are many agencies which are regularly monitoring the concentration of mercury in sediment, water, and fish every year. In that way, they can suggest consumers which fish are safe and which are not. And that is possible in some of the countries, especially US and European countries. They have some monitoring program, and they monitor regularly, and they suggest safe fish consumption for people. With this, thank you very much. Thank you for bearing with me.
Thank you, Dr. Chhatra, for this very interesting presentation. A little bit scary also, you know. I think we need to be careful what type of fish and, you know, where to, you know, fish, origin of the fish is also so important. So that's a very interesting presentation, Dr. Chhatra. And now I have seen some questions coming to the screen, and if you are ready, I will start picking up those questions.
Sure.
Yeah? Thank you.
Sure. I'll try to give answers as far as possible to satisfy them.
So Ramesh Basnit is asking, how can we reduce mercury concentration in drinking water? Is that an issue? What are the preventive measures he's asking?
Actually, in drinking water, mercury concentration is not much harmful. Actually, mercury goes into our body mainly through diet. That is the big concern. In water, mercury does not remain mainly as the methyl mercury. If methyl mercury comes in water due to photoreduction reaction, methyl mercury is converted into elemental mercury, and this elemental mercury is not much harmful unless it is ingested in very large amount. So in drinking water, generally we don't have such a problem of mercury pollution.
So just on this, thank you, Dr. Chhatra. Just on this, you know, I think, you know, we have heard this arsenic contamination. We have shallow tube well and deep boring, you know, tube well kind of thing in the lowlands. But that kind of thing, like arsenic in water, mercury in water, so that's not really a concern, health concern for us.
Arsenic is a concern actually.
Yeah, arsenic is concerned, but what about
But
the mercury?
Mercury actually, it's not in that high amount in water. But neurotoxic is mainly this methyl mercury, organic mercury, and it is mainly formed in anaerobic condition when there is no oxygen, and bacterial action and other reactions, sulfur reducing bacteria convert mercury into methyl mercury in lake sediments, natural waters where there is no oxygen, and that if that comes along with the diet, then that is major concern. But in rather than mercury in water, if there is a high concentration of mercury vapor in the atmosphere, that is a concern. So from water, there is not big issue for mercury, but through atmosphere, because mercury is released very easily in the atmosphere. So if it is found in very high concentration, it says 11 or something mg per cubic meter or something like that. But there is very less chance that that concentration prevails because it diffuses very quickly.
Very
So
quickly.
if there are some accidents in factories where they use vapor mercury, and if it is in confined room, and there were many accidents in such cases, but in open area, this mercury, vapor mercury, does not cause much health hazard compared to methyl mercury through diet.
Fantastic, because you said that they also go through this process of oxidation and things like that.
Yeah.
So thank you. Basu Bidari, how can we control persistence in the environment, mercury persistence in the environment, and other potential toxic effects on ecosystem and humans?
Mm-hmm. Yeah, there are many actually for shallow lakes and other. There are many. Sometimes converting this methyl mercury, which is bound to the sediment in shallow lakes, it requires a lot of work. It's like aeration at the bottom, like in some of the lakes in Europe and other parts, we have seen it, but it is not feasible in our context probably. Aerating bottom of the lake is highly expensive, so giving oxygen. So persistent, we can reduce, actually we have to be careful. And in Nepal, when we talk about Nepal, I have not seen these local sources of mercury, because we don't have factories that is producing mercury or other metals that actually release mercury as the byproduct. So if we produce more other ferrous and non-ferrous metals where byproduct is mercury, then it will be very much consumed. So until now, maybe I haven't gone to those areas for the research. That's what we don't know. Maybe there are certain areas where this rock itself consists of high concentration of mercury. So if we find, then there will be problem. But in other parts, generally in other parts from where we are consuming, this mercury in water is not much concern. But fish should be a concern. But in those three places where where our team measured mercury concentration, they are quite safe. But what happens if we consume large amount of mercury this week, and if we wait for the next week without consuming, we excrete it. And it is said that by many research that it flushes out from our body within 80 days. It's slow, but we can flush it out. So if there is no acute problem, then there will be no problem actually.
You said it flushes out. That means our cells don't contain mercury, even though we have been intaking mercury in small doses.
Yeah, intaking small doses actually does not hamper. If there is high concentration of methyl mercury and that passes to the blood-brain barrier, if it reaches to the brain, then it shows this nervous problem. Otherwise, small kidney can actually flush it out easily. With small, as I said, 1.6 microgram mercury per the body weight is safe limit. If we go beyond this, then we can have some adverse impact. But if we don't continue to consumption of fish for a few days, then it goes flushes out.
Right. So there's a good message for the fish eaters. Huh?
Yeah, actually.
So another question is somebody who doesn't want to be named.
Mm-hmm.
Does mercury harm those people who take bath in natural hot springs? Because there was one point you said mercury sulfide and that kind of thing. So just briefly, if you can.
Yeah, sure. Generally, mercury comes along with sulfur as mercury sulfide, and when it comes to the surface, then there is a reduction, then it converts into mercury and sulfide remains there. So generally it is said that in human body, mercury mainly comes through diet. That is the big problem. If fish contains very high concentration, for the marketing limit, it said that mercury having 0.5 mg per kg or 0.5 ppm, less than 0.5 ppm can be sold in the market. And fish in Nepal is less than this one. But another, it says that it does not enter through skin. Very less amount of mercury passes through the skin, so taking bath is no harmful.
No harm.
And ingestion is mainly by, if we ingest a lot of amount by vapor, that is problem. But with water, there is not much problem. That's why.
So the vapor that is there in in our traditional hot springs, that would contain mercury, no?
Yeah, if it is in confined wood, but it says that if it is more than 13 or 11 milligram per cubic meter of air, that generally that does not exceed that. To reach that concentration of mercury in atmosphere is really difficult. So if it is in confined room, some possibilities there, but it's in open area, then there is very less chance.
Well, thank you. We'll take another question. Som GC, do the lakes stagnant water tend to retain higher mercury concentration than the flowing waters, rivers and streams? I think yes.
Yeah, actually that's what is shown. Generally rivers flush out sediment, also they bring sediment very quickly, flushes out very quickly, so it removes mercury. But in lakes they have very high retention time. So, and mercury is converted into methyl mercury at the bottom sediment of the lake. So it flushes out very less, very slow rate. That's why fish in similar kind of fish in the lake, they will have a higher mercury concentration compared to river fish. Yes, many studies have shown this one.
Yeah, thank you. Mahendra Prasad Upreti, I think he is referring to the fish diet you mentioned at one point of the presentation. During the period of diet switch, how can they survive and continue the generation? I think it's the fish.
It's their own lifestyle actually. There are some of the organisms in nature which switch their diet, and fish, there are many fish species which switch their diet. For example, I mentioned one of the species, fish species in Norwegian water. When they are small, they completely feed on zooplankton or small insects only. But when they reach greater than 30 centimeter, and they actually try to find out what is the diet of less than 30 centimeter and greater than 30 centimeter of the same species from the same lake. And many studies have shown that they switch their diet, and it is their natural process actually. So switching their diet is not forceful, it's a natural process. So probably that's something natural process.
Thank you. Sushil Dahal is asking, I'm curious that how can we generate evidence that precipitation washes out atmospheric mercury? Is that washed out mercury detectable in rainwater, since this may contribute to very small amount of mercury? What could be the impact of rainwater washing out mercury from atmosphere and bringing it to the aquatic system? It's a long question, so you'll have to be brief for this one.
Actually, I could not hear at the middle. Maybe there was some problem, network problem.
Shall I go again?
Yeah.
So basically, you mentioned about mercury being washed being washed down, like the in the waters. So I'll just read. The washed out mercury, is that detectable in rainwater, since this may contribute to very small amount of mercury? So
it's a good question. This It depends on the instrument that we use to analyze mercury. And nowadays there are very sophisticated instruments that can detect even picogram of mercury that is present in the atmosphere or in the different samples. So sometimes it's not available. If we go for if we do not go for the sophisticated instrument, then it can say that no detected level. But there are very good instruments nowadays, and it can detect mercury concentration up to picogram. So some up to picogram, it's possible.
Mm. Yeah. So I think he has another question. What could be the impact of rainwater washing out mercury from atmosphere and bringing it to the aquatic system? I think you gave that very nice example of why the Gosaikunda would have higher mercury compared to PHEWA lake. And then, you know, that thing, perhaps Kathmandu air pollution is dumped there, mercury pollution. So, so there is impact, you would say, that there is.
From both wet deposition as well as dry deposition, means atmosphere particles during non-monsoon period, they also deposit there. So dust particles also contain mercury bound with those particles. That also brings a lot of mercury to the surface, both in soil surface and water surface. So if they, like with runoff, if they reach water body, and if sediments, the mercury goes to the sediment area where there is no oxygen, then there is a high chance that mercury is converted into methyl mercury. That comes to the human body. Otherwise, elemental mercury, it does not come to human body and pose threat.
Thank you. Gopa Haldar asking, how will we know which fish containing mercury? Is there a way to find out straight away?
Actually, it's difficult. Sometimes we can see that mercury in thermometer. When you break mercury thermometer, we can see mercury. But by examining mercury, by examining outer body of the fish, it's really difficult. It's really in low concentration. It's really difficult.
So you would not say something like you just grab a fish and you will see some kind of blue or red stain. No, you don't have that.
That's sometimes difficult. If there is a high mercury level, it could show some of the symptoms in fish, but fish does not show that kind of symptom in low concentration of mercury. It's visually it's difficult to identify whether there is high mercury or low. So regular monitoring by the government is necessary if fish industry is very good.
Absolutely. Thank you. So Samir Thapa has this question. You know, I think he's also surprised the way I am surprised that you showed in one of the bar that Kathmandu has higher mercury concentration in the air even compared to big cities in China. And that is really surprising because I mean, why would you think that Chinese cities have less mercury compared to Kathmandu? And Samir is adding that is it due to our own anthropogenic actions or mostly due to long-range transportation from our neighboring countries who perhaps pollute more than us? Kathmandu.
As far as Kathmandu Valley is concerned, there could be the very high chance that it already received a lot of mercury in its soil and others by long-range transportation. So it should have been comparable to Dhulikhel with Kathmandu. But there is also publication of one of the articles by showing the nature of which kind of particles are there in dust of Kathmandu. And they've clearly found out that most of the particles in Kathmandu atmosphere, Kathmandu dust actually, they contain more than 80% or something like that from cement. So products, and cement is one of the biggest sources of mercury. So, and another is fuel burning. And for example, in Kathmandu Valley, there are many brick kilns and they use coal. Is a major source of heating. So coal burning is one of the major sources of mercury, and traffic also is one of the major sources, and soil particles, because there is a lot of constructions going on here, and if you see, there is a lot of dust particles in the atmosphere from those construction places. So they are contributing high actually. Our own activity is releasing large amount of mercury, which otherwise are settled in the soil. In addition, traffic and coal burning, those are increasing. So biomass burning is actually arising as one of the major sources. Like we actually residue burning and biomass burning, even in Tri-region and Gangetic plain. And those are also bringing a lot of mercury along with carbon and other things during monsoon and other parts, yeah.
So there is a chance that something can be brought to Kathmandu.
So in Kathmandu, there is certainly some long-range transported mercury is there, but big contribution is due to our own activities like coal burning and very huge traffic here, as well as those construction things that is releasing a lot of dust that contains large amount of cement.
Yeah.
Yeah.
Thank you so much, Dr. Chhatra. Anagha Pandey is asking, which organ is likely to retain maximum mercury concentration in fish and in humans?
Actually, mercury, it is protein bound. Like if we talk about other organic pollutants, they are fat bound, they are found in fatty tissue. But mercury is protein bound, methyl mercury, and mercury, it is protein bound, so it is highly found in muscles. So, and there are different research actually. Gills also, they retain more metals, and kidney, and muscles, and liver. There are different other organs. There are many studies, but we are mainly concerned, if we talk about mercury, it is mainly protein bound, and the high concentration could be found in muscle as well. But this gill also, actually, it attracts a lot of metals. So mercury also found in high concentration in gills. Yeah. So protein, mostly in proteins.
Yeah, right.
And in human, actually, it's not the concern of where does it concentrate, but the main concern in human body is if it reaches nervous system. That is the main problem. If it remains in other parts of the body, it does not show health hazards. But if it reaches a nervous system, then especially in very small fetus, it passes through the placenta, methyl mercury. From mother, it goes to the baby. And in growing, especially scientists say that, many studies show that if mercury reaches brain during their growing stage, particularly 8 years or something like that, this is more dangerous compared to adult men and women. Yeah, so they must be more careful.
Yeah, thank you. So, I mean, so when the mercury goes to the brain, to the, and that's really dangerous. That's really, that can be hampering. But in terms of deposition in humans, it may not be affecting like in muscles or even organs. So is there, is there a site you would say where it gets deposited, but perhaps it doesn't affect, like Sarah Carling is asking, where is mercury deposited in human body, muscles or organ, so you need to.
Yeah, one thing is that if we inhale elemental mercury, for example, here, then it shows some physical process like corrosion in the alimentary canal. It can damage alimentary canal directly. That is physical action, corrosion we call it. If we engulf large amount of mercury, then it does not have neurotoxic effect. It immediately shows some impact in our digestive tract by corrosion, something like that. But if we eat mercury through, if mercury goes through diet like methyl mercury, then methyl mercury mainly shows its impact in nervous system. It damages neurons, this is what they say. So in other places, and if we actually get large, like engulf this elemental mercury, it is also said that if in a high concentration, it can also damage kidney. After digestive tract, it can damage kidney and liver as well. But if we talk about methyl mercury that goes slowly into our body by consumption of fish and other things, then we have to remain it is main concern with the neurons that passes to the blood and crosses blood barrier to the brain, and it goes and it damages neurons. That is one of the problems. So, and generally we don't take large amount of mercury anyhow. So if there is a very big if, so
just I think this may be the last question.
Okay,
You know,
yes.
there has been some query about fish from, you know, PHEWA Lake, because, you know, a lot of us have gone there, consumed
Yeah.
quite a bit of fish, you know, maybe
Yeah.
2-3 kilos a week kind of thing. But,
Yeah.
you know, in that slide, you showed that tilapia, which is a kind of predatory fish, isn't it? Predatory nature, is it? Tilapia.
I'll talk something about this.
Yeah,
It's
just can you
should I
give a little bit, because there is a little bit of confusion, because eel is having higher
Okay.
concentration compared to tilapia. Yeah.
Oh yeah, tilapia is actually not our native fish. It's a noxious fish, and it is uh, from actually it is spread from Africa, and it is found throughout the tropics nowadays.
Yeah.
It is started to invade entry in Nepal from eastern side. Now it's, if we go to Lake PHEWA and fish there, more than 80% of the landings is tilapia. And it is actually voracious feeder. It is not carnivorous. If needed, it can be carnivorous, but normally it can utilize those resources which are not used by others. So it can utilize, like it can consume plant parts. Now at this stage, tilapia, as far as possible, it is consuming plant parts and some decayed vegetation from the bottom. So especially those decayed vegetation, that's why it has a low concentration. But there is not much when I try to find out, search some articles about this feeding or feeding of this tilapia, it is found that mostly it remains herbivorous, basically. That's why it's considered. But while competing in the ecosystem, actually it replaces all others. It's very hard fish.
Yeah.
It can switch its diet very easily, and it can utilize the resources very effectively compared to other specialized fish. It is non-specialized, it is opportunistic, it can utilize any resource available, and it can compete with others, and finally it outcompete other native fish. That's why there is a very high risk that from Lake PHEWA, in long run, there is a very high chance that we actually, some of the native fish can disappear from that lake particularly.
Absolutely.
But now farmers are very happy. Actually, it grows very fast, and although it's not very tasty, it grows very fast, and they have a very lot of production of tilapia. Now farmers are happy, and even mercury, also very less mercury in there, because now its diet is this plant parts.
Quite varied diet.
Yeah. By pollution aspect, it's no danger, but from ecosystem aspect, there could be some danger. It can replace many other fish species actually.
Okay. Yeah. That's thank you so much for that clarification, Dr. Chhatra. I think you know, now we have come to the end of the program. Would you like to say something before we you know, we close the program? Just anything you forgot to say?
Thank you. As a take-home message, actually, whenever I present it regarding the negative part of mercury, then we think a very high risk in consuming fish and something like that. But generally, the benefit part of fish outweighs this mercury. Generally, we have to be cautious with those fish which are from highly polluted area. And in Nepal, those very local sources are very limited, and this long range transported mercury actually did not raise that much level of mercury in our fish until now. And we are also trying to find out mercury level in fish from Lake Godagodi, and we can see that how much concentration is there. So until now, in those three places, mercury is very safe. Okay, so we have to be careful, but it's not that scary actually. But and if we go through some literature in US and EU, they have clearly mentioned that from these fish from this area is very dangerous to consume. So that kind of monitoring is there, and I think we should go for the positive ways also. And mercury is not that at dangerous level in fish in Nepal, so it's a good news.
Thank you
for providing this.
Thank you, Dr. Chhatra. I think now I will start closing on behalf of the organizers and audience, I would like to thank you for sharing this, your important findings and knowledge on mercury pollution in our region. And we learned quite a deal. You know, we have had a lot of new knowledge today and on this subject. And thank you so much. We are not so scared about the eating fish from, you know, PHEWA Lake anymore. Perhaps Bagmati, that's another subject. And thank you for taking up all the questions also. Many thanks to audience for joining with us in this episode and for joining the Q&A session. And those of you who joined us a bit late, please be reminded that the entire presentation is available on Himalayan Nature's YouTube site. We'll be back with another presentation within a week. So please follow Himalayan Nature's page to find out what's coming next. But today, I would like to wish everybody goodbye and namaste. See you soon.
Thank you. Namaste.